So for those of you who don't know me, my name is Jeff Glatstein. I am the manager of the cyber infrastructure at WHOI. Happy Friday, and thank you for joining us. My understanding is this is the last time slot for AGU, so you are truly persevering, and we very much appreciate you joining us. A couple of years ago, we decided to look for a better way to explore our data, and out of that came the Data Explorer. We've got some panelists here today that are going to walk you through some of the new features of Data Explorer and then how they use it. Each will introduce themselves. So without further ado, why don't I pass it to you, Stacey, so we can talk about what's coming up on Data Explorer.
Great, thanks, Jeff. I'm Stacey Buckelew. I'm Director of Programs with Axiom Data Science. We are a partner to the WHOI program that has been working on developing the user interface for data discovery called the Data Explorer, which we're going to show to you today. The Data Explorer is a data discovery interface that allows users to find and access WHOI data. This new platform was first launched in October of last year following a user-driven design approach. And basically, this was an iterative development life cycle that began with a proof of concept, moved into a beta, and now into the V1 phase that you'll see today, where we engaged input from various institutions and marine researchers based on their needs for WHOI data. With this first generation interface, it does exist along the WHOI data portal, which is the previous or the current platform, to continue to maintain full data access as we continue to build out the Data Explorer. Next slide, thank you. You'll see a demo from researchers today with the existing platform, but I just want to let you know a little bit about the future. We're in the process of adding new data, features, and functionality to the Data Explorer, so just to keep you aware of what's coming next. You'll continue to see new data arrive in the Data Explorer. This includes high-frequency cable data, more complex scientific data types, including ZPLS, Opta, AUV data, in addition to underwater imagery and video data that we hope to host over the next year, as well as accessing raw data files. And we're in the process of building out a beta version of integrated Jupyter notebooks with an embedded search catalog that will allow researchers to run numerical analyses alongside the WHOI data within the Data Explorer environment. So I'm going to pass it over to the next panelist that's going to dive into the Data Explorer and show you some of the science use cases.
Okay, and that is, hang on a sec. Just over to you, Andrew, who is going to talk about response to Winter Storm Grayson.
I believe I'm sharing my screen now. Oh, there we go.
And you're good.
My name's Andrew Reed. I'm with the data team from the Coastal and Global Scale Nodes group with WHOI, which is based at WHOI. And today I'm going to be taking you kind of through a demonstration on how you can use the Data Explorer tool to look at the ocean response to a passage of a winter storm. So the winter and spring of 2018 here in the Northeast saw a series of nor'easters hit the mid-Atlantic and the New England states. The first one was nicknamed Winter Storm Grayson, and it passed by CGSN's Pioneer Array around 6 p.m. on January 4th, 2018. This storm was notable for having strength experience, what meteorologists call bombogenesis, where it strengthened by 53 millibars within 21 hours. And so winds on Nantucket reached nearly 76 miles per hour, and Boston saw 17 inches of snow. So we can start in what I have queued up here is a data view, which I put together showing some of the meteorological and sea surface characteristics for the passage of that storm. So down here, we can see the MET data and which includes the barometric pressure and the wind speeds, along with the maximum average wave height from the central surface mooring at the Pioneer Array. And so the time scale here starts at midnight on January 2nd and then runs through a week. And we can see where the storm occurs with pressure dropping from nearly 1,025 millibars the day before the storm. And you can see the storm come, the pressure rapidly drop to nearly 968 millibars, with winds reaching 20 meters per second and wave heights of nearly 10 meters. And then you can see the passage of the storm, the return to standard winter conditions. And we can look at the sea surface temperature here, where we see kind of on the same time scale leading up to the storm. You can see it's kind of cold. And then we see this rapid warming of the sea surface temperature. Similarly, with the passage of the storm, we see the sea surface salinity increase with the passage of the storm. And that is kind of a atypical response to kind of the canonical thinking of wind and storm driven mixing in the upper ocean, where we typically think wind and the waves induce a lot of mixing, and that mixes down through the thermocline, bringing up colder waters from below. But in this case, we see kind of the opposite thing happening. So that leads to the question of what's going on underneath. And so in order to do that, we can actually try to go take a look at the central profiler mooring, which is located really close to the surface mooring. And that should give us a look at what was happening underneath the water at the same time. So we can go to access array data. We want to go to Coastal Pioneer. We're looking for profiling assets. We want CTD because we want to look at the temperature and salinity. So this brings up lots of the data. So here we go. Right at the top, we have this. We see lots of our profilers, and we're looking for the central profiler mooring over here. Wire following profiler. Can go take a look and see. All right, we've got that same week, that January 2nd to midnight to January 9th at midnight. And we can see kind of starting out, we have this. So warmer waters are these light colors and colders in dark. And we can see before the storm comes, we have a warmer water layer with kind of a broader thermocline and then a cold freshwater top. Then the storm comes and we can see that wind and wave driven vertical mixing. It erodes the thermocline, and we see the profiler become much more uniform throughout the depth. And you see warming up here. And then kind of as the storm passes, we see this odd kind of snapback where the surface water actually get a deeper, colder layer, and the thermocline becomes much more sharp. So the question is, does that also happen with, what does the salinity look like? Because you wouldn't expect warmer water to be stable underneath colder water. So we can just go back, and so we can instead select salinity under that profiling assets with the CTD. Find that same one, central profiler mooring, salinity as CTD. And now we can see kind of what happens over that same time period. We have fresh water is in dark, saltier water is in light colors. You can see layer of fresher water on top of saltier water with kind of this broad halocline. When the storm passes, you get that vertical mixing, which erodes the halocline, and then you get this re-stratification, the much sharper halocline following the passage of the storm. So that is kind of one way that you can use the Data Explorer to go look at the result of the passage of this, in particular, notable winter storm that happened in January of 2018. That is what I have for using Data Explorer to kind of investigate a particular event. So I will pass it back to Jeff.
Thank you. That was great. Having experienced the storm and shoveled through it, it was very interesting to see how it reacted with the mixing. Do we want to do questions now, or do we want to wait till the end?
Let's do questions now.
Any questions out there?
If you have one, raise your hand and I'll unmute you so you can have a discussion with Andrew. Let's see.
John Trowbridge.
Andrew, that was really nice. Thank you for spending time to put that together. You mentioned how odd the response was after the mixing during the storm. And you said it was a bit of a mystery. Do you have any ideas about it? I mean, could it be, that we've got warm, salty water offshore and cold, fresh water onshore, and some exchange that was happening laterally instead of vertically, for example?
I mean, that's certainly a possibility. And you could go take a look at the other moorings in the array, which would give us an idea of the spatial pattern across the shelf break there, which would allow us to kind of piece together the horizontal response to the storm as well as the vertical changes.
Okay, thank you. That's a good answer.
It looks like the panelist has a question.
Yeah, that'd be me. So I was just going to ask Andrew. I like the data view and the background that it provides. I guess one question would be, how long did it take you to create the view? And then another one would be on the Data Explorer website. There are 6 data views, that are shown, and I guess I'm wondering whether this one might be a nice one to add there. That's pretty nice. Thank you. So yeah, how long did it take to make that view?
The actual data view itself was pretty easy to put together. Maybe 30 minutes of playing around with figuring out which charts go where and which ones look good with each other. Most of the time was spent actually looking at the data, trying to figure out which data kind of showed what happened with the passage of the storm. So it was fairly intuitive.
Okay.
And I should mention for all the attendees out there, you can create those data views yourself and save them. And then if you want, there's a tool at the top that you can click and share with other people.
Thanks.
Yes, thanks for saying that. I was going to remind folks that any user has the ability to create those views. Okay, next up is Wendi, Ruef, and Mike Vardaro for the Axial Volcano eruption forecasting.
Right. Hi, I'm Mike Vardaro. I work with University of Washington on the Regional Cable Array. And Wendi, your video popped off my screen, but I think you're there. Oh.
Sorry, I am here. I'm Wendi Ruef, and I'm work on the data QA/QC team for the OI array at UW as well.
So we're going to give a brief overview of a different data view, and also sort of how to put one together, and also where the data come from. So if you start on the oceanobservatories.org website and go over here to Data Explorer in the top, that will take you to the entry page that was being shown earlier. So this is the Data Explorer main page, and this is where you would access those data views that Ed was just talking about, and that Andrew hopefully will add the new storm one too. So these are the publicly shared ones. But you can also just, you can quickly access data from any of the arrays, and you can sort of see where they are here on the globe. I'm going to go to the cabled array since that's the one I work on. So this gives you a map of where the cabled array assets are located out here at Axial Seamount, as well as, so the cable runs offshore from Pacific City, Oregon, out down to a southern line that runs around to the slope base, and then Hydrate Ridge, and then a couple of the Oregon offshore and then Oregon shelf sites. And you can zoom in and see a little more bathymetry. And I believe you can change the base layer to look at different different bathymetry backgrounds. I believe the OOI one has the most recent bathymetry from some Mbari data. So you can see the caldera of this active volcano known as Axial Seamount. And if you want to actually then go look at the data, you could say choose Ash's vent field and pick one of the nodes. So this is the medium power junction box located at Ash's vent field, a hydrothermal vent field within the caldera of the Axial Volcano, and see quick plots of all of the different instruments that are located connected to that junction box. Alternatively, if you wanted to go back to the overview, you could start again, or just go back up to all instrument types, and then you could just go. And this is every cabled instrument on the system, and you can then pick different parameters. This one is, so you're looking at the list of instruments here on the left, instrument types, and so you can say look at every CTD. There's 64 different CTD parameters, and then narrow down your parameters using this interface. I need to silence my Slack, sorry. And yeah, so you can get a quick look at different types of data that are coming in through the cabled array in real time or near real time. But we are going to now zoom in on a particular event and data type. So if you, let's see, happen to catch one of the earlier booth presentations, or Bill Chadwick or William Wilcox presentations at AGU this week, you probably heard about Axial and the magma chamber that is building up underneath. And Suzanne Carbot also talked about the magma chambers. So the magma chambers are building up underneath Axial, and every so often they erupt into lava flows on the seafloor, along with explosions and earthquakes. And one of the ways that people are looking at the data in order to tell when the next eruption is going to be is by looking at these bottom pressure and tilt sensors. So this is all the bottom pressure and tilt units and all the parameters from those instruments. They're complicated instruments with a lot of different sensors on board. And so you can narrow down and say, okay, I just want to look at bottom pressure, or I wanted to look at mean seafloor depth. So that's a good way that scientists are looking at the inflation and deflation of the seafloor. So as magma builds up underneath, it pushes the seafloor up. And then when an eruption happens, that magma chamber collapses and the seafloor drops. So you can actually see that in 2015, there was an eruption. You can see that the seafloor was inflating and then dropped suddenly. And if you wanted to, say, create a data view in order to look at that eruption, you could zoom in on that and then say, I want to add or remove this data set from a data view, and you would create a new data view or save it, or you could go to the one I already created that talks about this axial volcano eruption forecasting. Wendi, am I forgetting anything about?
Oh, you're good so far.
Okay, so this is a data view about the eruption in 2015. So in 2014, these instruments came online, which was lucky because in 2015, in April, there was a large eruption at this site. You can see here, so I added mean seafloor depth and mean seafloor pressure plots to this data view. Sorry, I just scrolled up and down real quick, but you can trust me that there's depth and pressure here. And that creates a little map here showing the location of these instruments that the data is coming from within the caldera here. So there's the Ashes vent field, the central caldera site, eastern caldera, and I believe international district, unless I have international district and Ashes mixed up. Anyway, there's a number of different nodes that are connected to the cable that have bottom pressure tilt units attached. And you can see here, you can create a comparison chart with data from these different tilt meters and sort of look at what happened in 2015 and then what's been happening since. And then if you want to, you say, okay, so this is the data from 2014 to 2019. I want to go look and see what's happening now. So you can click and that'll take you to, let's see, it's the central caldera one. Okay. So then you have, again, this is the particular instrument in central caldera. And you can say, okay, I want to look at mean seafloor depth. I don't know why that's cutting off in 2019, but you can say, okay, I want to look at pressure. Then that, and that'll get you to a full screen view. And you can see, so this black line is the average, the mean data, and then you have the max and min during the week, and then you can zoom in and get, you can see tidal fluctuations here, but, and then we also have links. So in that data view, did I go with the data view? Go back to the data view. Within that, I had some links to other work being done by William Wilcock and Bill Chadwick. So the Zoom controls are getting in the way here, but I'll just go to, so this is Bill Chadwick's eruption prediction site using data from these bottom pressure tilt units. So you can go there and see the latest research being done on trying to predict when the volcano will erupt again, as well as William Wilcock's earthquake catalog site, which is using data from WHOI as well as his own processing to look at earthquake activity within the caldera. So this is from seismic sensors and hydrophones within the caldera, also hooked up to the cabled array. So this is earthquake activity in the past 24 hours, 7 days, 30 days, and then showing the number of earthquakes that occurred on a plot here. I think that was everything that I was going to talk about for this part. Wendi, did you have other?
I was gonna add, if you want to download the full resolution, because through what you're viewing right now in the Data Explorer is 1 minute averages, but the sensor is actually sampling much at a higher frequency than that. And so you want to show them where to get to the full resolution.
Right, good point. So if you want to do more investigation of the data, you can download the data in a number of different ways. So this will get you the data that you're looking at in the plot here. You can also close that. You can also go to the source. So that will take you to what Stacey was talking about before, the original data portal, and you can download the full resolution data. There's also ways to get the full resolution data directly here. So you can click on this and you go to all downloads, and you can get the full time series or deployment by deployment data from the threads catalog or ERDAP data set in a number of different formats from the Data Explorer site itself. As well as seeing annotations of incidents that may have occurred or interruptions in data, and additional information about the instruments and the types of data products that are produced by the instruments. So there's a lot of metadata as well. And you can see the annotations here as well. Time series. Soon we'll have quality control information displayed here using some Cortod plots that are being worked up. Anything else, Wendi? Should I turn the ball over to you? Did you want to show any profile stuff?
No, I think between this one and Andrew's, they have a good sense of what data is available. The only thing you might want to cover if there's time is how to make that comparison plot that you have on the data view.
Yeah. So when you add, so I'm going to save this to the data view. And then once you save it to the data view, you get this other, I don't know if it's easy to see.
Mm-hmm.
It's easy to see on my screen because I have a large monitor here, but I can zoom in a little bit. So when you click this star over here, it saves it to the, you can click the box to say save to your default data view. And you see there's no data added to the comparison chart yet, but you can also, you can say add to comparison chart, and then that one will be added. And then you can go back, find a new data set, and then add that to your, go back. Central there, junction box, save data view, add to comparison chart, and then now you see there's two plots there. Good point. And then you can add a description and a label to your data view, or add a new data view. And download images. Yeah, so there's a number of options here, and then there's the share link up here to share it with other people. Okay, I think that'll take us to the end, and we can answer any questions if people have.
Oh, we're waiting for questions. One thing, I don't know if folks noticed, you can add content into that data view that does not necessarily come from Data Explorer as well. So there was some very nice graphics and write-up in that, and you can add that.
John Trowbridge has a question.
Good job, Mike and Wendi. That was a nice talk, and really appreciate the effort you put into preparation. One thing that William Wilcock emphasized in his talk, and also Tim Crone during the Pangeo talk, was the connection between the sea level data, or the seafloor level data that you showed, and the OBS data showing earthquakes. And you mentioned that as well from the catalog. I was just curious if you ever looked at the OBS data from Data Explorer itself to see if anything interesting would pop up.
OBS being ocean bottom seismometers. I have not looked at the seismometer data myself, not a seismic expert. I believe the links from Data Explorer take you to the IRIS portal, which is a repository. I'll show that. Hold on. So if we go back to the data view, So seismic data are available through IRIS, which is a seismology catalog that takes in seismic and hydrophone. And I believe we're also sending our bottom pressure tilt data to them as well. And they serve up a lot of different types of seismic data and provide a lot of different visualization options once you're familiar with their interface, which I'm not 100% familiar with their interface. But, this is the main way that we are serving out the seismic data at the moment. Although I believe we are working, well, not I believe, we are working on different ways to visualize the earthquake data as well, to create sort of a 3D visualization of earthquake locations within the caldera.
Okay, thank you, Mike.
Yep. Your hand's still up, John.
Okay, if there are no other questions, then over to Ed Devitt, who's going to talk about in-situ water bottle sampling.
All right, thanks very much. And I'm actually going to talk about a little bit more than the bottle sampling. I'm going to talk about the bottle sampling and the cruise and glider selector tool, which is a capability that's in development. So yeah, I'm Ed Dever, and I'm PI and project scientist for the Coastal Endurance Array of WHOI. And in contrast to Wendi and Andrew and Mike, who work on the data team and are, kind of expert users of the data, I think I'm a little bit more like the average user of WHOI that kind of comes there and has not as great a facility with stuff. So I'm not going to show you a data view. I have created data views and found them to be pretty interesting and useful for classes, but the process of watching me create a data view would be painfully slow in contrast to what Mike and Andrew showed you there. So again, I'm going to talk about initially the cruise sample data, and this is motivated by one of the WHOI exhibit booth talks I went to earlier, and one of the questions that somebody had was, are you taking physical sampling? And the answer is yes. The physical sampling data has always been available through the WHOI document repository called Alfresco, and there are links to that document repository from the existing or the old WHOI data portal. However, as part of the Data Explorer effort, the WHOI 2.0 data team, including Wendi especially, and Andrew and Mike here, has really led an effort to put the WHOI discrete sampling data into a common spreadsheet format that can then be imported by the Data Explorer and accessed through the Data Explorer. So what I'm showing you here is, let's see if we can get to, am I sharing the WHOI Data Explorer screen? I guess that's the first question.
Yes, you are.
All right, thank you. So what I'm showing here is the initial kind of look at the cruise data, and the cruise data is pretty small in its size, so it loads pretty quickly. Some of the other stuff I kind of have preloaded here. The cruises are organized under this cruise data tab by the array, right? So here we have, it's by the array and it's by the cruise name, and that's a little bit inconvenient in the sense it doesn't tell you exactly when the cruises took place. Different ships use different cruise naming conventions, and so some things you can kind of suss out right here. If you see SKQ 2018-08, well, yeah, that seems like it's August 2018, or it's the 8th cruise, sorry, in 2018. But other ones, for example, AT 3703 down to TN 394, it's just the cruise number of the specific ship. But what you'll see here is this is AT 3703 is highlighted right now, and you can see this is, I've just reduced it to just the water temperature, but you can look at all parameters. And these are basically all the bottle data for the cruise, and the pH data sometimes has issues with the preview being available, but all the data is there. And I'm just going to simplify it just to show the again the temperature. As you go through here, you can see it's September 2016 through October 2016. That's that cruise. But what I'm going to show here, for example, this is the cruise TN 394. This is September 9th through September 22nd, 2021. And this is all the bottle data there. And it's presented kind of in a time series format. But what you can do relatively quickly is you can just hit the download button. And although it just shows, we're only showing the little plot for water temperature there. If you hit the download button, you will get all the cruise data. And again, it's not a huge file. So it downloads, this kind of stuff downloads pretty quickly. And I'm just going to show you a quick example of one of those files, and it's from this TN 394 cruise. And so, again, you get the whole Excel file there. I've hidden a bunch of these columns, but one of the things we're interested in on the endurance array is the issue of the development of hypoxia over the summertime, and the moored oxygen sensors, they do biofile over time. We have issues with growth on those sensors. We try to mitigate that as much as we can with most recently UV light as an anti-fouling measure. But you might be interested in comparing oxygen data from the bottle samples with oxygen data from the moorings, and this is one way you can quickly click on and get to that cruise data. And so again, I've hidden some of the columns here. This is actually the CTD oxygen from the shipboard profiling CTD. These are the discrete oxygen samples, and then I've just got these are the bottle depths, lat and lon, and then over here is the time. And so that's just showing, just highlighting what you get if you're interested in looking at the oxygen data. As I mentioned, I've hidden all the other columns here, but you can go through and you can look at bottle samples, for example, from PCO2, dissolved inorganic carbon, and as well as calculated values from there as well. So that includes, like I say, chlorophyll, nutrients. All the bottle samples are downloaded when you click this download for a given cruise. So that's the cruise data selector. It is organized by array. And so, for example, if you're interested in the cabled array data as well as the endurance array cruise data, you'd have to go back and look through the regional cabled array and go to the cruise data there. And again, you could click that and download it relatively quickly. So that's the cruise data. But I'm also pretty interested in the glider data, right? So one of the issues with the glider data is there's a lot of it, and we often fly a glider in different areas, right? So this is using the initial pop-up from the glider in Cruise Selector, and so it shows you different glider data right here. And when you sort of highlight the entire time series, it shows you where the glider is flying. So there's a glider that's flying on the Newport hydrographic line of the Coastal Endurance Array, but we have other gliders. If we kind of look down here, for example, here's a glider that was deployed off of Oregon, sent up along 126 West, and then out to the Grays Harbor line. And you might say, well, I'm only interested in the Newport line right now, so I want to get part of that glider data, or maybe I'm only interested in the Washington line, so I want to get part of the glider data when it's flying up on the Washington line. And that's where this kind of developing glider and cruise selector capability is really pretty nice to kind of select some of that data. And so what I've shown next here is an example, right? So in this case, I've thought, well, I'm interested in glider data from the Washington line. And I'm also interested in the 2021 upwelling season, right? So what I've done here is I've used the slider bar to kind of put the upwelling season, thinking about, okay, we're starting in March through the end of May. That covers the spring transition to upwelling and essentially the months of March, April, May. And you can, if you want to fine tune that, you can go over here to the calendar, but I usually kind of use this selector first on the time. And what you'll see here is this shows you kind of where the gliders were operating during that time. If you move this selector bar backwards or forwards, you'll see an increasing number of points or a decreasing number of points, depending on what you're interested in. The other thing I've done here is I've built myself a little polygon. And what that polygon does is it selects the data that are within that polygon, and then this is the data that are within that time. When you come over to here, you will see the whole deployment, right? So for example, here, that's the whole deployment. But when you go to download the data with this filter, it will select the data that are within there. So it's a pretty nice tool for identifying and grabbing data, and even just kind of seeing if the data are, if there are data that exist at the time and location that you're interested in for the glider data. And right here, I've just shown water temperature, but for example, you can click if you'd rather look at the dissolved oxygen concentration in seawater. It'll take a little bit right here, and it'll kind of come out to dissolved oxygen concentration in seawater. And again, kind of going in micromoles from 91 up to 200 right here. And that kind of jibes with kind of some of the levels of, oops, well, I'm not going to go back to, let's see if I can go back to this right here. From low levels of oxygen near the bottom up to higher levels of oxygen near the surface. So you can kind of, I'm not going to do the kind of anything more than a rough qualitative comparison, but we're kind of getting things that are in the right ballpark there compared to our discrete measurements. So anyway, these are capabilities that are under development. If you look carefully here, you can see a few issues that I'm going to look at and I'm going to work through with folks from Axiom. Right now, this ends kind of August 9th, 2021. And then here, these are telemeter data, which are pretty useful. But in some cases, we've got the full recovered data set. And what's being shown here may not be the telemeter, or we might be able to do better than the telemeter data set. So there's a few issues to sort out. But again, it's a pretty useful capability. I think if you're looking, like I said, for isolating a piece of a glider deployment that's on the transect that you're interested in particular, or if you're looking for availability of data, etc. And that is what I got to share.
Fantastic. Any questions?
John Trowbridge, it looks like you get your hand up.
Yeah, let's talk to I was interested in what you might be getting from comparing glider data with mooring data. Since they're on different time scales for fouling, is there any value in that?
Well, so I'll say, quite frankly, I haven't done it yet, but I will. But you can, you can make this. You can make this. Let's see here. Take a while to update, but you can make this. This box kind of as small as you'd like. And so, for example, here we've got the Washington offshore profile or mooring. And if you were really interested, for example, in comparing glider data to the Washington offshore profiling mooring, and you have to double click the last one right here, you can select a pretty small polygon and just pull that glider data, and for example, then you could compare nearby glider profiles with profiles from that profiler mooring or from near surface platform data. Again, if you really are a stickler, you can zoom into the point where you can actually find individual glider profiles and compare them to these are all sort of individual profiles right here, and you can compare them to the mooring. So you can set with this little box, and you can move this thing around a little bit if you want to make it, you know, a little bit better than kind of a crude thing. So like I said, I'll confess I have not done that yet, but it is something that is possible to do.
Okay, thank you, Ed.
Okay, and Saj had a question. It just disappeared. Okay, so the question was, is the cruise CTT cast data available yet in Data Explorer in the works? And Andrew mentioned that it's currently is just bottle data, which is the data from the .btl file, as well as the discrete sample analyses from the Niskins.
Yeah, and I'll say that I think I was looking at the different cruise data. It looks like the endurance data and the cable array data has all been ported over to Data Explorer. I think there's still some CG data that is yet to be ported over. I think there were you know, to do that porting over, the files have to be perfect, and I think Andrew, I think the files are all fixed right now, and it might just be a matter of asking Axiom to reload the cruise data files to get the remaining CG ones there.
CGSN still has some cruises we need to put together from Pioneer.
Okay.
Our
Okay.
globals are all but except for one or two done.
And again, those are still available on those are available on the data portal, but I think it's, you know, within those spreadsheets, any little kind of carriage return or whatever can affect the automatic kind of porting of them over to Data Explorer.
Okay, any other questions?
I'll just say one more thing is that the WHOI glider data that's here on Data Explorer is actually hosted by the IUS glider DAC. And so if you're a person that is familiar with the glider DAC and you like the glider DAC, then WHOI glider data is being sent, both the recovered data and the real-time data, over to the DAC. So that's another place, again, if you're more familiar with that portal.
Okay, if there are no other questions, once again, thank you all.
And Mike has pointed out DAC is Data Assembly Center, right? So yeah, just for the non-acronym enabled. Thank you.
And sometimes we don't realize we're using acronyms when we're so familiar with it. Thank you to all the panelists. I appreciate your efforts on this, and thank you to everybody who joined us today. Have a great weekend.
Thank you.
Thanks, everybody.